Welcome to the deep dive. Today, we're plunging into a topic that might seem super technical on the surface, but really it's the hidden engine powering so much of our digital world. Think streaming, critical business apps, you name it. Our mission, like always, is to, go beyond just scratching the surface. We want to pull out the really crucial insights from some pretty specialized stuff.
Yeah, and for this one, we've got excerpts and practice questions from the 2V0-13.25 VMware Cloud Foundation exam. Now, it is focused on the exam, sure, but the real takeaway for you listening is understanding these core principles, modern data center design, how it all works. It's basically the architecture that makes the cloud, cloud. We'll unpack how those components fit.
Exactly. So by the end of this, you should have hopefully, a surprisingly clear grasp of VMware Cloud Foundation VCF. You know the key concepts, the components, essential design stuff. Think of it as a shortcut to getting up to speed on this really critical bit of IT infrastructure.
Right, so to set the stage a bit more, this material is from an exam prep guide.
Yeah.
So for anyone who maybe interacts with VCF or is even thinking about getting certified, what are the basics of this particular exam, like the practical details?
Okay, sure. So it's pretty comprehensive. You're looking at 64 questions, and you get 130 minutes for those. Passing score is 300 on a scale from 100 to 500. Question types, they vary. Multiple choice, multiple select, drag and drop, that kind of thing. And the cost typically is around $250 US. So yeah, those details kind of frame the level of depth required, Okay, that makes sense. So to really peel back the layers on a VCF solution, we've got to start right at the beginning. What problem are we actually solving?
Requirements, right. And,
Yeah.
and it seems they aren't always straightforward. Let's take a scenario from the material. Someone insists on having a single pane of glass for management. Is that fundamentally a business need, or is it purely technical?
That's a great question, and it's a really crucial distinction. Get it wrong, and projects can go sideways. See, a technical requirement is measurable, system level. The solution must support X number of VMs per host. It's about the system's capability. A business requirement that's focused on the outcome. So things like reduce operational costs by 15% in year one, or meet a 99.9% uptime SLA. That's a service level agreement, basically your uptime guarantee. Those are business goals.
Right. So a single pane of glass for management, that squarely fits as a business requirement. It's addressing an operational outcome for the user, making management simpler, not a specific system function itself. Sometimes engineers, they might misclassify it because, technology is involved, but the why behind it. That's the business need for efficiency, less complexity.
That really clarifies it, and it shows how important it is to, make sure IT efforts actually line up with what the business needs.
Okay, so once we're clear on what we're building, the next step is mapping it out, right?
Right.
The blueprint. How do you get from those high-level requirements to an actual plan? And what's the real difference between a logical and a physical design in VCF? Yeah, there are definitely two distinct stages, and there's a clear sequence. Think of the logical design like an architect's initial drawings for a house. It shows the rooms, their purpose, how they connect, but not the specific brand of pipes or wires. In VCF, a logical design might say, okay, we need 2 clusters, and they need NSXT enabled. It's the concept. The physical design then takes that blueprint and translates it into actual hardware-specific connections, configurations. That's where you list the exact server models, the switch ports, the IP addresses. Logical first, the what, then physical, the how.
Logical what, physical how.
Got it.
And every good design, it seems, has these core principles guiding it. Let's say an application needs its data replicated to a remote site, and it has to be recoverable within, say, a 2-hour window. Which design principle are we really talking about there? Manageability, performance, recoverability, availability.
Okay, that scenario. That points directly to recoverability. That principle is all about the ability to restore service after something goes wrong, a failure, a disaster. That specific 2-hour recovery window, that's a direct measure of recoverability. How fast can you get back online? It's different from availability, which is more about preventing the downtime in the first place. And performance, that's about speed and responsiveness. So yeah, the recovery window is the dead giveaway for recoverability. It's about minimizing the impact after an event.
Okay, recoverability it is. Makes sense. All right, so we've talked strategy, we've talked blueprints, but a blueprint doesn't build itself. Let's dig into the actual pieces, the components that make a VCF environment tick. For instance, which VCF component is the central brain, the one responsible for automating the deployment and the whole lifecycle management of the entire SDDC stack, vSphere, VSN, NSXT, all managed together.
Right, that would absolutely be the SDDC manager. It really is the core automation engine for VCF. It handles the whole 9 yards. Initial deployment, configuration, ongoing stuff like patching, upgrades for the entire stack, vSphere, VSAN, NSX. This is where VCF really changes the game.
Yeah.
It shifts IT from these manual, sometimes error-prone builds to more of a factory model. It's not just faster deployment, though. It cuts down operational work, ensures consistency, and lets your team focus on, well, more important things than just racking and stacking and configuring over and over. It's a fundamental operational shift.
That makes total sense. So if it's that central, I'm guessing it's one of the very first things you set up. Like when you're first bringing up a VCF environment, that initial deployment phase, which component gets deployed first? The main entry point.
You got it. Yeah, during that initial bring-up process, SDDC Manager is the very first thing deployed.
Yeah.
It absolutely acts as that central starting point. It then orchestrates deploying all the other critical pieces, vCenter, NSX, getting vSAN configured, and so on. Without SDDC Manager being up first, that whole automated deployment train just doesn't leave the station.
Okay, let's switch gears slightly to isolation. Imagine you've got like general workloads running, but then you also have a dedicated, really isolated workload for maybe a specific business unit, something sensitive maybe that shouldn't share resources or networks. How do you achieve that kind of logical separation within VCF? Keep them apart.
For that specific need, VCF uses something called workload domains. They're designed precisely for that, providing logical separation of resources. Think of each workload domain as sort of a self-contained mini-cloud within your bigger VCF setup. Each one can be managed on its own. It gets its own vCenter instance, its own compute, storage, network resources. So this lets you carve out distinct isolated environments. One for your general stuff, another totally separate and dedicated for that specific business unit. Ensures that their resources aren't impacted by others. It also gives you flexibility, right? You could have different security rules, maybe even different chargeback models for different domains.
That sounds really powerful, especially for bigger organizations. Okay, so we've designed it, we've deployed it using SDDC Manager, we've maybe set up some workload domains. Now, how do we keep this this potentially complex system healthy and running well? Let's talk upgrades. Before you even think about upgrading VCF, what's the main reason for doing a pre-check? Is it just like ticking a box?
Oh, definitely not. It's absolutely a critical step. You really shouldn't skip it. The main purpose, the primary purpose of that pre-check is to validate that all your VCF components are configured correctly, that they're healthy, and essentially ready for the upgrade. It checks compatibility, looks for potential issues. It's all about significantly reducing the risk of something going wrong during the actual upgrade itself. I mean, backups and rollback plans are crucial too, of course, but the pre-check is about preventing the problem in the first place by confirming you're good to go.
Right. Proactive versus reactive. Makes sense. And when things, inevitably do have issues, especially maybe network connectivity, what's the most effective first step for troubleshooting in VCF? It feels like there are so many layers, physical network, virtual network. Where do you start digging?
Yeah, that's a good point. What often gets missed, especially because VCF heavily relies on NSXT for networking, is that many connectivity problems are actually in the overlay network, the virtual layer, not necessarily the physical switches and cables right away. So the most effective first step, use the NSXT command line interface, the CLI. Check the health of those overlay tunnels. Check the status of logical switches, maybe the distributed routers. You can use pretty simple commands like get logical switch status or get tunnel health. This lets you quickly see if there's an issue within that virtual network layer before you start chasing physical connections.
Okay, start virtual, then go physical if needed. Good tip. Staying on this operational theme, how do you make sure that the VCF management domain itself, where SDDC Manager, vCenter, all those critical bits live, how do you ensure that's highly available? What's the key design decision there?
Right, for the management domain's high availability, the fundamental design choice is sizing it correctly from the start. Specifically, you need a minimum of 4 ESXi hosts. Those are the physical servers running the VMware hypervisor, the foundation. Why 4? That specific number is crucial because it allows vSAN, the storage component, to have enough resilience. It can typically tolerate at least one host failure without losing data or management capabilities. And it provides the necessary capacity and fault separation for high availability, or HA, for all those essential management VMs. So yeah, building in that redundancy with at least 4 hosts is key.
4 hosts for the management domain.
Got it. Yeah. And one last operational point, capacity planning, specifically for storage with vSAN. When you're planning for growth, making sure you don't run out of space, what's the most critical metric to keep an eye on for a vSAN data store in VCF? Is it latency, CPU, health score, or just plain old free space?
Yeah, for vSAN capacity planning, it unequivocally boils down to free space. VMware's best practice recommendation is pretty strong on this. Try to keep at least 30% free space available. And that's not just an arbitrary number. That buffer is essential. It allows vCN to do its internal operations, like rebalancing data as things change, or if you modify storage policies. And crucially, it provides enough slack space for data recovery if a disk or even a whole host fails. Now, don't get me wrong, health score and latency are definitely important for performance and knowing the current state, but for planning, free capacity is number one. It tells you how much runway you have left.
Wow, okay. 30% buffer. That's significant. So here's a final thought to maybe chew on. As this kind of software-defined infrastructure like VCF becomes more and more the standard, what new skills become really critical for IT folks who aren't maybe VCF specialists but still need to work within or alongside these complex environments? Something to think about. For now, thanks so much for joining us on this deep dive.